Then I should write this dy over d theta. This is depend on the subject, and this represent the subject. This is the standard notification of differentiation. If we differentiate, if we differentiate y with respect to subject w, then dy over dw. Then we can find this dy over dx. If there are x things, we should differentiate with respect to x. If there are theta things, if equals y 2 theta plus 1, we should differentiate this. Okay, we should differentiate this with respect to theta subject. Okay, with respect to theta subject. Okay, with respect to theta subject. That's the things. And at first, I differentiate this. So if we are using first principle, the first thing is we should write this. Change of y is delta y for a delta exchange of x. Okay, for a delta exchange of x. That means if I if I change this x from delta x, then the change of y is delta y, because these are functions. That's the thing. Because these are functions. If I change x from delta x, then y also change from delta y. Then we can write that. Okay, we can write that the change of y is delta y relevant to the change of x is delta x. That is the main thing that we should write. Okay. Please wait. Stand with some phones. Okay. This is the first principle. Okay, this is the first principle. Then just wait. Uh, don't write anything. Huh? Don't write anything. This thing. Now I erase this. I erase these things and keep this with your mind. Why did you get this? You understand this? This becomes y plus delta y, x plus delta x plus 1. Okay. Is it okay to you?
Yes, I think, yeah. Is it like if you are adding uh change of y? If you're doing some change to the y, you should do the same thing to
No.
the x kind of.
No, we are do the change to the x. If we are do the change to the x, then y is depend on that. The y is the
Oh,
dependable. We first we do the change to x. Relevant to that change, y also change by delta y. That's the meaning of that.
oh, okay, okay. Got it, sir.
Uh,
Thank you.
okay, okay. I think Sophie and Sunil know issue. So I erase these things and I do that problem. Then our problem is y equals x plus 1. Now we should write this change of y is delta y with respect to the delta exchange of x. Then after writing this, we can write y plus delta y equals x plus delta x plus 1. Then we should get 1 and 2. After we get these equations, definitely in all problems, we should subtract 2 from 1. It is a primary step. It is okay for any calculation. Then 2 minus 1, it is y plus delta y minus y equals x plus delta x plus 1, x plus delta x plus 1 minus x plus 1 minus x plus 1. Then y and y cancel out, delta y is remaining x plus delta x plus 1 minus x minus 1, x and x y cancel out, then delta y equals delta x, one's also vanished, one's also vanished. Then delta y equals delta x. Okay, now we should get this. Delta y over delta x equals 1 now. Now, this is especially for Maheli. Sophia will know these things, but I don't know. Do they remember these things? Huh? Can you tell, Sophia or Sunil, what is the definition of dy over dx? What's the definition of dy over dx? Sophie, can you tell? Show your colors. Huh? What's the definition of dy over dx? Maheli, you don't know. But after this day, you know, you should remember this. You should remember the definition of dy by dx. The dy by dx is the differentiation of y with respect to the subject of x. Yeah, limit delta over delta x. The delta x is going to what? Limit delta y over delta x. Maheli, this is a standard definition. So you should remember this. Delta x should be limit to 0. When we are doing these limit things, I will help you. So don't give up. Okay. This is the definition. You should directly write this. You all should directly write this. If you are doing differentiation by first method, okay, by first method, only in first chapter we are doing this first method derivation. After that, I will teach you a smart method, and after that we use that method. We are not using this method not locally. Okay. Okay. Mahir, did you get this? Is any doubts or something? Mahir, yours, you can ask. Hurry up, quickly.
I think it's all right for now.
You can directly write you can directly write this. No issues. Okay, delta y over delta x equals 1. Now dy over dx is limit delta x to 0, limits delta x to 0. What is delta y over delta x now? Mahiri, if we put delta x 0 directly to this expression, it will go into infinity. Yeah? So don't do that. Because of that, we did do this calculation and find the value of dy over delta y over delta x. So we can substitute that for this place. Then what happened to delta x? No worries, because there is a 1. So equation is 1. So the differentiation is 1. As a summary, y equals x plus 1. The differentiation of y with respect to x subject is 1. That is the summary. Okay? The differentiation of y. We can get this one step up after I teach you the smart way. But don't leave steps. We should go from step by step. Okay. Did you get it? Okay.
Yes.
Okay. Quickly get this to your book or paper. Sophie and Sunil, I think no need of writing this. Maheli, please quickly take this to your paper or book and update me. Yeah? If you have any doubt, you can ask me. Sophie and Sunil, I am very sorry and give me some support. After this, we can go together.
I'm done actually. I start writing a little before, so yeah.
No, excuse me, I can't hear.
I'm done writing down because I start writing out a little before, so I'm
Okay,
done writing.
okay. Okay. Sophie and Sunil, you do the homework, your homework, y plus 1 over x. Okay, now you finish that homework. Okay. What's the answer? What's the differentiation of dy over dx? 1 over x. Ah, I sent. Okay, let's see. Mahali, okay now? Did you finish this?
Yes, yes, it was done. Done.
Uh, okay. Now I'm doing the homework that I gave last week. Homework is y equals 1 over x. Now, maybe see, yeah, always same steps. Y equals 1 over x. Then we should write this. Change of y is delta y with respect to the delta x change in x. This is 1. Then we can write y plus delta y equals 1 over x plus delta x. This is number 2. See, same steps. Always delta y and delta x. Now, we should subtract 2 by 1. Then y plus delta y minus y. 1 over x plus delta x. Okay. Should be subtract from 1 over x. Now I get this thing and y will be cancelled out. In here delta y. Delta y equals. Here we should get a common denominator. X minus x plus delta x. And here x plus delta x dot x. I got a common denominator. Then delta y equals x minus x minus delta x. Here x plus delta x multiplied by x. Now delta y, x will be cancelled out. The minus delta x is remaining. Now x plus delta x dot x. Then now we know, no, take always delta y over delta x. That's the thing. Delta y over delta x. Then here minus 1. Here x plus delta x dot x. Now we can write the definition. Dy over dx equals limit delta x to 0, then delta y over delta x. Now limit delta x to 0. Delta y over delta x is, we can substitute by this minus 1. X plus delta x dot x. Limit delta x to 0. Okay. I think you can get easily the answer, no? In here, it's no issue of substituting 0 to delta x because it's not going to infinity. It's not arise any undefined destination in mathematics. No undefined things. If I substitute 0 to delta x, the answer is minus 1 over x plus 0 is x, no? X plus 0 is x, but it should be multiplied with x. Then it's 1 minus 1 over x squared. This is the answer. Sunil, okay? Sunil, is it okay? This is the answer. We get these things in one steps, in our combined maths paper, in our A-level paper. But this is first step. Okay. Don't worry. There is a special method to get these differentiations. Okay. Get these things. Okay. Okay. Well done.
Sir,
Yeah.
the very last part, that the second step from the end of it, like where the
Okay.
from
This way.
bottom the second one.
Yeah. This way. In this is step or this step.
No, on the third column.
This.
Yes, yeah.
Okay. Okay.
So would you mind explaining it again, how move forward from there?
Yeah. Can you repeat again? What the problem in this system?
I did not get how that became the answer. Like,
Okay. 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 Please. Did you get? Did you get I substitute delta y over delta x instead of delta y over delta x. I substitute this from this. Is it okay?
oh, for the entire thing.
Yeah. For the entire.
Okay.
Yeah. For the entire thing. For the entire thing. I substitute this. Is it okay?
Yes, got it.
That is
Yeah.
why. That is why we going through this painful process. Okay. That's why we go through with this process to take the delta y over delta x value. Then we can substitute. That is the all in all calculations. This is the way.
Okay, got it, sir. Thank you.
Okay. Now delta x 0 we substitute 0 to this simply minus 1 over square. Okay. Okay.
Okay.
Sophie is Sophie. I think you. Sunil. Okay. Sunil, if you have any problem, you can take. You can ask.
Nice problem.
Okay. Right. Okay. Then this is the first principle. We just do the first principle. We have to go a long journey in differentiation. Okay. Okay. There are some small questions to differentiate by first principle. Okay. You try it. Definitely, you should differentiate these things. You should differentiate these functions only by the method of first principle. Okay. Only by the method of first principle. The y equals x squared. Y equals x squared. You try. You should try. Okay. First of all, you should write this. Change of y is delta y. Change of y is delta y with respect to the delta x change in x. Now you can write y plus delta y equals x plus delta x entire. Square is for entire thing. X plus delta x square. Then this is the equation number one. This is the equation number two. Now simply you can subtract 2 by 1. Then you can easily put the delta y. We know that y plus delta y is subtracted y and y vanish. Only delta y is remain. Delta y in here x plus delta x squared minus x squared. In these steps, please apply difference of two squares like mathematical tools. Definitely, you should apply those things. Delta y equals now x plus delta x minus x plus delta x plus x. Okay, I'm stopping this step. I want to know whether you got this so any issues in here. In this step, any issues? Anyone? Hello? No issues? No, sorry, okay, no, thank you. Sunil, no issues? In this difference of two squares? No. Maheli,
No issues.
in this step, the difference of two squares? No?
No.
Okay, okay. Then this x is cancelled with this. Then delta y equals only delta x is remaining. In here, x plus x. See, this x plus this x is 2x. Then 2x plus delta x. Then you can get this delta y over delta x. Delta y over delta x is 2x plus delta x. 2x plus delta x. Then write the original definition of differentiation. limit delta x to 0, delta y over delta x. Just put this instead of delta y over delta x, it is 2x plus delta x. See, it's very easy, no? Yeah. When I put delta x 0, its answer is 2x. The answer is 2x. This 2 is keeping this place. So 2x. As a summary, y equals x squared, then dy by dx. We say simply dy by dx is just 2x. Soon I will teach you the smart method, the short method, taking this. So please say it. Okay, do these things. Furthermore, not a painful process like this. We can just get this, okay? But I should teach these things because according to the teacher's guide, okay, we can't leave these steps. Okay, so quickly, hurry up. Okay, now. Okay. What about Mahir?
Okay, sir.
Okay. So try this. Y equals x cubed. Okay, try this one. Oh, there was no chats, no? All messages sent. Sophia notes. I didn't see your messages. Okay. 3x. Is the answer 3x? No, 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 no. But close to it, huh? Not 3x. But 3 also there. But x is in another form. Something should be added to x. Not adding, not adding, not subtract. Adding. Some part is added to. Just answer 3x squared. If I differentiate this, y equals x cube. Just dy over dx is 3x squared. Is enough of the pattern, sir. No, no. Today we do that. Today we do that. So please wait. Today we do that. Huh? So don't worry. Did you get this? So guess the pattern. Okay, guess the pattern. If there is y equals x4, then dy over dx is 4x cube. 4x cube. If the function is think x cube plus x4, then the dy over dx is see 3x squared plus 4x cube. Can you guess the pattern? I teach this, I explaining this very deeply how we get this, but I just tell you. So don't do these things, still don't do these things. You should go with our painful process for the last time, for the last time, okay? Mahili, especially you, is it okay? If need, you can get, you should get the differentiation of y, this answer by the method of first principle. Please update me whether you do not. Okay.
Yes, sir. Got it. Got it. Okay.
You got it? Got it? The answer?
Yes, sir. Yeah.
Okay, well done. Okay, Sophie, okay, got it? Yes, well done. Sunil, did you get this? 3x square?
Yes, sir.
Okay, well done. Then, right, differentiation of, this is a topic, this is a topic, right? Differentiation of special type functions. This is the type, saying the smart method. Differentiation is special type functions. Okay. Now think, if we have all together, see, if you want to get the differentiation of nth power of x, nth power of x. Now we are going to get the differentiation of nth power of x. See how we pronounce it. Differentiation of this n power of x with respect to the subject of x. What is the answer of this? If you are getting your answers by through mic, it's very easy for me. What is the answer of this? What is the answer of this? Please tell. What is the answer of this? Tell the thing. Someone the answer. Yeah. No answers. Please tell. Tell this. Easy now. What's the answer of this? The diff two. Sunil, what's the answer of this? Maheli, what's the answer of this? The differentiation of x squared by the subject of x.
Cube of x.
Excuse me?
X cube of x.
No, not x cube, not x cube. Okay, guess the pattern, huh? This is 2x. This is 4x cube. This is 9x 8. 8th power. Did you feel something? Did you feel some mathematical pattern or something in this? Anyone?
Yeah, like uh, the power goes to the number and it the number before that becomes the power.
It's -1. I think Sophie, you're okay. Sophie, okay. You got that. Maheli? I think Maheli also got that. You saying power is getting to the front of that.
Yeah, and
Then what happened to the power? Subtract by 1, no? The 1 is subtract from that, no? Did you get it?
yes, yes,
Yeah.
yes, yes.
Very good, very good, very good. Sophie, okay. Yes. Yeah. This can be written as, see, 2x 2 minus, see, Sunil, 4x 4 minus 1, 9x 9 minus. Then what's the answer of this? N. Get the number of power, get the power in front as a coefficient. In front of this, power is n minus 1. Okay. Okay. If you are okay, please write that. Okay. If you are okay, write and you can do anything you like. Highlight, take that, anything. But quickly. Now we should prove this. Now we should prove this by method of first principle. Okay, don't worry, yeah. We should prove these things by method of first principle. Then we can use directly, yeah. Okay, don't write these things. Okay. Okay. Is it okay to erase these things? Is it okay? Did you all finish these things? Hello?
Yes, sir. Yeah.
Oh, okay. Okay, thank you. Sophie, Sunil, okay? Okay. Now we want to, okay, no. Yeah. We should prove this. To prove this, we should get that function. We should get that function, but which is n power of x equals to y. And then we can differentiate y with the method of first principle. Okay, please write our usual notation, our usual statement. Change of y is delta y with respect to the delta x change of with respect to the delta x change of x. Then you are free to write this. Y plus delta y equals x plus delta x. Put nth power to this entire thing. Get this as first. Get this as second. Okay, so please say try, but I didn't know how to expand it. Okay, don't worry, don't worry. But I appreciate your try. I appreciate you. Very good. 2 minus 1. Not to worry. Not to worry. Your try is the best. Okay, 2 minus 1. Simply delta y is remaining. Now x plus delta x n minus xl. Oh, before this, I have to teach a theorem in limits to Mahevi. Sophie and Sunil, okay, you know Mahevi. Mahevi, there is a special two theorems in limits. In this proof, we have to use it. Sophie also, I think, is stuck in that place. Sophie, you can't expand this. You should apply theorem in limits. Okay, you should apply theorem in limits. I want to say those two theorems for Maheli. Maheli, think about this. If we limit x to a, if our function is this xn minus an over x minus a. Mahit, don't worry about these things. I just directly write these things. So don't worry. This is also a standard connection. It is standard thing. So don't worry about that. We should uh, we should adjust our expression in this format. Okay, in this format. If we think this, there is a limit. We have there's a limit to calculate in this format, and it's telling x is limit to a. Just substitute x to a. What happens? A to the power n minus a to the power n. A minus a. What's the answer? Answer is 0, 0. 0, 0 is an undefined format in mathematics. Do you know that? I asked it from Mahir. Do you know that? Is it 0 over 0 is undefined format in mathematics? Do you know that? Please, Mahir.
No.
Oh, okay. Don't worry. Okay, it's an undefined format. Okay. Now, if we get 1 over 0, 2 over 0, they are also not defined correctly. But we can put something for that. It is infinity. Okay, it's infinity. Finally, you take the last page of your book or separate paper and write you should write these things up. not in our standard theory now. Get some paper or something. And Sophie and Sunil, you also, if you okay, yes, Sophie, good luck. Very good. Okay, well done. Well done, Sophie. Okay, Maheli, please tell me, and Sunil and Sophie also, if you need these things, you can write. Maheli, write these things in a separate table.
Done, sir.
Okay, okay. Then, did you write this also? Did you write this also?
Yes, yes.
Yeah, yeah. I need space below this. Huh? Below this, I need space. If there is not, write it again. Okay. I need space in your book below this. Okay. And Mahali, see this. Sunil, did you get this? Sunil also. Great, Sunil.
You
Yes,
have
Sunil, did you get it? Get it? Here, clear.
Yagano, sir.
You got it. You got it. Okay. Mahali, did you see some relationship between this and this? Did you see some relationship between this and this?
Yeah, n equals 7 and 2 equals a, right?
Yeah, a equals to n equals 7, no? Oh,
Yes.
yeah, that's it. That's it. Was is I think that no, is it? Um, if not for the hint you gave. Ah, yeah. Yeah. But by solving many problems, you get that experience easily, yeah? After this lesson, okay. Don't worry about that. You did it. That's the main thing. You did it with hint. Okay. And well done. Then, finally, the theorem is this. If you see, if you are stuck in such a situation, don't worry and don't write it as 0 by 0. It's undefined now. There's a mathematical theorem in limit lesson. We can easily write this. We can easily write this in this format. This is also this is also in the differentiation smart method, no? See, there is a relationship in the differentiation method also. No. We are going to prove this. It is not in here, but the answer is same. Okay, Mahali, is it okay? N a to the power n minus 1. It is okay.
Okay, sir. Yeah.
Then the limit is important. The limit should be definitely goes to A. If it goes to another something else, we can't apply this law. Therefore, to apply this law, definitely limit should goes to what? Can you mind guess? Mind can you guess? To apply this law, to what number it should be limit?
S- it should be 7 into 2.
No. See this. See.
Oh, that should be 7. Oh, yeah, okay. 2. Okay.
Yeah, okay. Okay, well done. Okay, good. Now, what's the answer? 7, 2.
Into 2.
Yeah, don't get these minus things, huh? Only the number. There are no minuses in here. Not minus it get to this place, okay? No minus ones. 7, then is 2. What's the number? 7 minus 1. Okay. Why is it okay?
Yes, yes, all clear. So,
Okay. I will put some exercises from this theorem after the class. Sophie and Sunil were done those exercises, and I will put the exercises from this theorem to you into the group, and you can practice with it and ask for me if you have any difficult places. Okay.
yes.
Okay. Now I erase these things. Okay. Okay. Sophie and Sunil, I think you are well now. Okay. Okay then this is the answer of. Now there is no delta x here. Now there is no delta x. We can't get any delta x to the denominator here. Okay, now Sunil and Mahali, I think. Are you in this system? Sunil also got that, no? Mahali, you are okay to this system? To this, is it no problem?
Yes, yes, yes. Yes, sir.
Okay, and understand, like previous problems, we can't get any delta x from here to denominator, okay? In here.
Mm.
So we
Right.
have to follow smart techniques in these type problems. So please focus. Now, first we should write this. The standard definition of differentiation: limit delta x to 0, delta y over delta x, and limit delta x to 0. No, no option. Now no option. Only the chance to substitute only for delta y. X plus delta x in power minus x to the power n. So we can't get the difference of two squares here. It will be very difficult. No, we should put delta x, no options. Okay. This is the smart trick that we should use here. Straight limit delta x to 0. And you don't worry about these things. You don't worry because you can't do those steps. I also in when I'm in A levels, I also stuck uh, in these places. But with experience and while doing some many complex problems, I got that experience. Okay, so don't worry and remind these special techniques. X plus delta x n xn. I am going to apply the special theorem we learned about. The theorem is, we know limit x to a xn minus an over x minus a. Now the pattern is going through according to the numerator xn minus an. Here it is x plus delta x to the power n minus x to the power n. Okay, Mahim, can you think now x is now x plus delta x. N is here, n is here. N is here, n is here. Now a is now x. Did you get that?
Uh, I think so.
Okay. No, don't worry. See, xn minus a. Xn minus a minus xn.
Oh, okay, okay, yeah, got it, sir. Yeah.
Okay. And see, in denominator, it is x minus a. It just without 10. in our standard format, the denominator is just expression without these powers. Did you got it? I
Does that mean that uh, for our problem too, we can just remove the power and just put it under the?
no, not removing, not removing, not removing. I mean, it's like that. Not removing any end, nah? Not removing any end. It's like that, but it's like that. Okay? It's like that. It's minus it. Okay?
Okay, so yes.
Not removing anything. Nah? Okay. Now, see, we can write delta x as this now. X plus delta x minus x. Oh, see, we can write delta x. I think I know. See, the Sophie's get this use this technique uh, along. It's very good, Sophia. You did that. I don't tell. I don't told about that. I think Sunil also got that. Maybe is it? Are you okay with this? We can try delta x. X plus delta x minus x. Is it okay?
No, didn't get how that came in.
No, no. See, when x is vanished, again delta x. So we can write delta x as this. That's why I did it. We can write delta x like this.
Uh, in that pro.
This is also delta x minus see x minus x. The delta x is given here. Okay.
Yes,
Yeah.
but the power, the nth power,
No, that's it. Okay. Yeah.
the nth power. How do you remove that?
Oh, I didn't remove anything. Now I am going to now I don't do anything to this. Okay, no relation
Oh,
to.
okay, okay. It's a denominator. Okay, okay. Now I got. Okay.
I'm going to remove this. Okay, I'm going to remove this.
Got it. Got it. Sir. Yes.
Okay, now x plus delta x minus x. Now you see the pattern. Okay, fine. Tell me now you see the pattern. Okay, now.
Yes. Yes. Yes.
Okay. But now, see, we can't use this limit in here. That's the thing. We can't use this limit to apply that law. So we please be careful about in here. Okay, you can't apply the law with this limit. Sophie and Sunil. If you apply the law with this limit, the wrong, huh? Okay, we should limit x limits to a, no? X limits to a here. See, when we are applying this law, x limits to what? X limits to a here. Then just wait. Yeah. Then see. Okay. Please wait. See, x in here, a in here. Okay. X in here, a in here. X goes to a. Now in this, x plus delta x should be limit to x. Okay. This limit should be changed to x plus delta x to x. Okay, see, x limits to a, x in here, a in here. So we to apply this law, Now x plus delta x should be goes to x. Do you get it? Okay. Did you get the change of limit here?
Mm, not really.
Okay. See. Sophie, did you get it? Sophie and Sunil? Okay?
Yes, sir.
Okay, Sunil, okay. Mahali, this is the Mahali. See, we want to write this like this now. N minus 1. To write that, limit should be always limits from x to a, from
Yes.
x to this. Then in here also we are ready to apply that theorem.
Yeah.
Okay, this format also now, okay, but
Yeah.
limit should be goes from this to this now, like this.
Ah, okay. So it's not gonna be delta x. It's gonna be okay now.
Yeah. Then don't please wait. We should write this, but we can't write this directly. We should use this limit. First, we use this delta x to 0, and now we adding x to both sides. Okay, then x plus delta x to x. Please write these things by a side, okay? In your simplification paper, write in by a side. Now you can write this limit. Now all are okay. X plus delta x to x. Write this x plus delta x n minus xn and x plus delta x minus x dot. Cut off these things are. We build these things so very difficult. Now you can write this also a critical point in writing the answer, final answer n minus 1. Now n, the a is x. Okay, it's very easy. Did you remember? We put this directly in our highlighted equation first, and we prove that. Okay, done. If you have any doubts, please ask me. Now all are okay. Now we don't need to follow the first principle, the painful process. No need of that. Now we can just get the differentiations by 2 steps or 3 steps. Okay, please write this and finish these things. Okay. Mind if you have any problems, ask me. If not, write and give me an update after
Okay.
finishing. Okay. And Sophie and Sunil, you can ask anything, any doubts, you can ask me. Huh? Sunil or Sophie. I see the performance of Sophie today is very marvelous. Well done. Yeah, no. I see the performance. You great. Good job today. You perform well. Sorry. Okay. Welcome. Really? Okay, okay. Thank you. Thank you for your words. We can do other units also like this. And after this one, we doing our doing this page yoga by scheduling 2 classes per week and the question, backup class and other all things. Okay, we don't smoke this one. I think is it okay to erase this side? No, really? Is it okay? No. I think no any harm to you if I erase in this place, this color.
Yes, sir.
Okay. And I will put some questions to you. Now you can no need to follow first place, fella. Just derivate. Okay, the differentiation. Is it? I see the message. See. See. Oh, really, I'm doing good. Okay, thank you, Sophie. Very good. Oh, okay. Thank you for your words, huh? Yeah, I do all works in this class then. Okay, learn, learn all things and ask from me in problematic things. And it's when you are stuck in problems, always ask for me to your help for you. Okay, I'm very happy about your words. Okay. Then, okay, y equals x cube. Now we know, you know these things, and I want to say tell another thing. The we call the derivation of y. Yeah? That is also a word we use for dy over dx. Dy over dx is telling first derivation. These are theory. First derivation. The derivation is the word. First derivation of y. First derivation of y. Okay. We tell also that word also. Then the derivate, get the derivation, get the first derivation of these things. It may be some questions like that. And differentiate this, you know already. Now y equals x minus 2, differentiate these things. Y equals 1 over x to the power of 5. Then y equals root x. Y equals 1 over third root of x. Do all these things. Okay. Mahedi, after you find these things, give me some update, okay?
Yes,
Notes.
done.
Okay, okay. Okay, Mahedi, you also try these things with our new theorem. Huh? This is not the new theorem. The new theorem is the derivation theorem. The theorem is what's the theorem? See how I write this? See how I write this? See? See? This is the correct way to writing this, the differentiation. Excellent. Now what's the answer? N x. Don't forget this x, huh? Now these are not limits now. This differentiation, so don't forget this x, huh? There's n a minus n, don't get that. Okay. Try this also. The first derivation. In this lesson, we learn these are also. This, see, what's this? This is the second derivation of y. Okay, don't worry about these things in this lesson. We do those things in future. What's this? The third derivation of y. Likewise, we can differentiate again and again expressions. And don't forget that by finding this differentiation of functions, we find gradients. If we find the gradients of the function, any complex function, we can find the gradient by using the method of differentiation. Okay. I'll give some time to you. Mind if you have any problem, please ask me. Yeah? Don't. Okay, so px squared minus 2. Yeah, second one also okay. Mm, very good. Your steps are also very clear. Ah, in third one, you should get in front of the x should be minus 3, you know? It should be minus 3, you know? See? Okay, don't worry. I'm filling this spot. Okay, not a serious error. What about other ones? If any uh, problems, sweet. Okay, if any problems, please don't hesitate to ask. Okay, okay. This first question of y. Y plus x cube. Then dy over dx is dx cube over dx. Then what's the answer? 3x squared. Why? Is it okay? Ah, okay. Okay. Why? Is this okay? Very good. Sunil? Sunil, what about this? Is it okay? The second problem is this. The second problem is y equals x minus 2. Then dy by dx is dx to the power minus 2 over dx. Then minus 2 x minus 2 minus 1. Then what's the answer? Minus 2 to x to the power minus 3. You can write this in this format also. In this format also. Okay? Any, if any you can use. Now, what about the second question? What about the second question? Hello, don't hesitate and ask me if any problems. Okay? Sunil, Sunil call ako. Sunil, නැද්ද ඉතින් Sunil? Sunil ඉන්නවට කතා කරනවා. Sunil, සිල් දෙයක් නැහැ. Hi Sunil. Is this okay to all? Maheli? Okay? This
Yes, sir.
yeah. Why did you finish all problems? In what problem? Now you are in.
Oh, half is true actually.
Half here. This.
Yes.
Okay. Now we should write this as in this format. To apply this law, we should write this in this format. And now we can apply dy over dx equal dx to the power half dx. Now get half. Get this half in front of x. Put x. Now half minus 1. What's the value of half minus 1? What's the value of half minus 1? Directly say, yeah. Don't simplify this like these things. Okay? What's the half minus 1? What's the answer of half minus 1? If you don't know, keep this in mind from this. Okay? From this moment. What is the answer of half minus 1? Directly say, yeah. We know 1 minus half. The answer of 1 minus half is half. Then half minus 1, it is minus half. Okay, directly get those things. Then half x to the power minus half. That means 1 over 2 multiplied by x to the power half. The final answer is 1 over 2 root x. Simplify to this point, please. Please simplify to this point. Do you simplify to that point? Or who did this problem? Did you simplify to this point? Is this your final answer? Is this the final answer in your problem sheet? And remind these things. It's very useful in this lesson and in integration. These things. Please tell me, is it okay? Is it okay? Is it okay now? Sophie, is it okay? Mary, Sunil. Okay, Sophie is okay.
What is it?
Okay, okay. I think my any problem here?
No, understood, sir. Okay.
Right. Then this third root also there, no? Third root also there. Then we then get the problem y equals 1 over x to the power 5. Now we should write this as y equals x to the power minus 5. Y equals x to the power minus 5. Now we can differentiate this dy over dx, the differentiation of x to the power minus 5 with respect to x. Very easy. Get minus 5 in front of this x and please be careful. This should be minus 5 minus 1. So it's minus 6. Minus 5 minus 6. You can simplify this into this final step x to the power positive 6. Okay. Write these things. Don't forget this minus 1. I see this topic also again. But forget this minus 1. No? I think you correct that. Okay. Now this is the final problem. These are not equal, these things. These are separate from this. These are separate things. These are separate things. Okay. Is okay. Okay, Sunil. What about other two key one resource? Okay.
මේ ඔක්කොම එකතු වෙලාද ගණන් එද්දි ගණන් එන්නේ?
මොකද්ද? සුනිල් මොකද්ද?
මේ ඔක්කොම එකතු වෙලාද ගණන් එද්දි ඒ ඔක්කොම දන්නවද?
බය වෙන්න එපා. ඩිෆරන්ෂියේෂන් කරන්න ලේසි. ඒ කියන්නේ ඩිෆරන්ෂියේෂන් එක අමාරු වෙන්නේ අමාරු නෑ. ඒ කියන්නේ මේ වගේ මේ ඔක්කොම එකතු වෙලා තමයි එන්නේ. නමුත් එකතු වෙලා හොගියා අමාරු නෑ. මේ අපි පාස් පේපර් සෙක්ෂන්ස් කරද්දී අපි බලමු සුනිල් එහෙම බය වෙන්න දෙයක් නෑ. මමත් දැන් ඒවා ඉගෙන ගත්ත පළවෙනි දවසත් තිබ්බනේ. I also had the very first day learning these things. I also overthink about these things. So very magic for me. But when I doing past papers after these practice sessions, when I did past papers in the time of my A level, there's no issue, not hard. Differentiation is okay, but integration is somewhat hard. Okay, it's logical, somewhat logical. These are also logical, but integration is somewhat logical. The integration lesson is after differentiation. The reverse process of differentiation. Okay, the reverse process of differentiation. It means this. In integration, the thing we do is they gain this. They gain this. We are integrating this to get this. X to the power minus 1. That is the thing we do in integration. The next lesson after differentiation. Don't worry about these things. And the other hardest parts are, do you know other hardest parts in combined maths? Yeah, that is integration. Other hardest part is uh, applied, applied part. Applied part we should study very carefully. Don't worry, I will guide you in correcting. So don't worry. Integration is the biggest part of the differentiation. It's also very interesting. Yeah, mechanics. Yeah, somewhat in mechanics, a simple harmonic motion. Indeed, the applied mathematics, studying applied mathematics is studying the theories in physics somewhat deeply. That's the thing. In combined mathematics, applied is studying physics, mechanics things. No any heat, no heat like lessons, no current electricity, no such lessons. The mechanics, the deep mechanics in combined mathematics. Okay, deep mathematics, deep mechanics. The physics, in physics, it is very simple mechanics. Simple mechanics, not classical mechanics in physics. Relative combined mechanics. So very hard. In nowadays, they don't ask very hard questions in applied paper. In past papers like the 1986, 1975, 1990, 1995, wow, great questions in past papers in applied paper. But nowadays, they don't ask any very hard questions. The all questions are going to same pattern nowadays. So don't worry, but I solving those 90, 90, 99 and 96, 90, 67, like this some hard problems I solved it in the class when we doing applied science. Uh, so don't worry about anything. Follow me. Don't worry. Okay, our final problem, y equals 1 over third root of x. Why did you get this? Why did you get the answer for this? If not, don't worry, please tell me.
Not sure.
Okay. Sophia and Suman, did you get this? No? Hello? Oh my god. This is the question here. Sunan, is it okay? I think I know the problem is with this, no? Okay. The problem is with this. Yeah, cube root. Finally, we can write this as this. Simply this. You know this, no? Okay. If this is 4, finally, this is 1 over 4. Fair. Fair. We can get n. Then x to the power 1 over. So it has just root. No. No. Then write this y equals 1 over x to the power 1 over 3. And get this to numerator. X to the power minus 1 over 3. No differentiate. Dy over dx plus d. X to the power minus 1 over 3 over dx and get this minus 1 over 3 in front of x. And please be careful in this place, minus 1 over 3 minus 1. I recommend you find this in a separate place, please. Find this minus 1 over 3 minus 1. Find that in a separate place, please. Please find that in a separate place. Then this minus 1 minus 3 minus 3 and minus 4 over 3. The final answer is minus 1 over 3 x to the power minus 4 over 3. That's the final answer. And if you like, you can get this. No issue of that. Okay, this is also no issue. This is also suitable as final answer. If you like, take this. Get this to denominator. No worries. Okay. Please finish these things. Okay, can I clear the board now? Okay, can I clear the board now? Is it okay? Finished? Okay. Everything's okay. So it also. Now write the topic. Fundamental theorems on differentiation. Fundamental theorems on fundamental theorems of differentiation. If k is any constant, what would be the differentiation of a constant? Previously, we differentiate all x terms, all variables. What should be the differentiation of a constant? Okay, any suggestions? Yeah, it is zero. It is zero. How it becomes zero? See, the meaning of we differentiation a constant. The meaning of the differentiation a constant means differentiation this. We can pull out this k here, then d, the differentiation of x to the power 0 with respect to x. Now get 0 in front of this, and x to the power 0 minus 1, this 0. That's how. So this is the first fundamental theorem of differentiation. This is the first fundamental theorem about differentiation, and you can write this by side. The second one is when we are differentiating the function like kfx with respect to subject x, easily you can pull out this constant. This k is any constant is valid for all theorems, and you can just differentiate fx, only fx. You can differentiate only fx. You can easily pull out k outside. That's the third theorem. They are very easy theorems. Huh? Then second theorem. The third theorem is this. If an instance we have to differentiate like the function like this, think about it. We are going to differentiate a function like this, fx plus gx now. You can differentiate those things separately, like this. D fx with respect to dx plus d fy. We are differentiating not entire one. We want the differentiation of entire one, but according to theorem, we can differentiate the components separately. So if this is y, see, if this is not y, it's a mistake y. It's also fx plus dx no, but I put y here, and I see that how is it cannot be happened. That's why I see if it is y, the subject should be always y, but it's not not y. I do some mistake, but I told you about subject. So it's this is the theorem. Try these things. Okay. Can I use the board now? Okay. Can I use the board now? Well, okay. Yeah. Yeah. It's okay. Yeah. Okay. Then it's okay. Any problem? No. Good. Please write down this. The problem is understand. Third point, second part is fx the gx. Oh, gx. It is gx. Please wait. It is gx, not fx. No. Please wait. The problem is some problem is 10. If this is not fx. This is gx. No. Thank you, Sophie. This is gx. Please, if you write it as fx, please change that. Both my ideas, Sunil. There's a fourth one. There's a fourth one. Fourth one is this. Fx minus gx. You know, this is very simple. Do dx fx minus do dx gx. So write it quickly, like this also quickly. Hurry up. Don't think our differentiation, the methods are not over, not finished those things. There are many more special things in these lessons to study. And there are not just the rules, the many rules are also the chain rule. Do you heard about those things? Chain rule, like that. Okay. And there is a main problem in here. Anyone should ask about that. I think any one student, even one student asking about that. Related to this, there is are there no any problems in here? Not in the theorem, but if these are like this, but no any problem. Not any problem in theorems. I asking about you. I asking from you something a doubt next to this. Okay, and you think about fifth theorem? It should be a fifth theorem. No, what's that? I mean that. No any questions like this, sir? I mean you are yeah you got it. Okay. What about multiplications and divisions of these functions? Can we get that multiplications also in this way? We can uh, we can differentiate separately. We can differentiate separately when two functions are added. We can differentiate separately when two functions are reducing. Then what about this? You should ask these things from me, huh? But why I specialize these things in here? This is the reason. See, we can't get the multiplications and divisions in this way. That's why I told you there are many more things to study in this lesson. Nah? This is not a finish. This is not an end. Okay, but no hard, not hard. By following the way step by step, all we can understand properly. Okay, okay. But keep it in your mind. We only can differentiate separately. Only there are additions or subtractions. But when there is multiplications or divisions, we can't get those. Write these are also in your paper. Okay. If you have any uh, problems in these explanations when I did here in this about this, feel free to ask. Okay, we can't get that. We can't get like this. Okay, write those things also. And I teach you the methods that we use to differentiate like in these expressions. Okay, there's some methods in later. So write these things. Okay, okay. Can I erase the board now? Okay. It's okay. It's okay. Sunil, yeah, it's okay. Sunil, is it okay to erase this? Okay. Now there are some practice problems. We'll go see these, huh? Quickly. Y equals 5x cubed. X to the power 3 over 2. The y equals 3 into x to the power 5 minus 7x 4. Y equals x cube minus 3 root x minus 1 over x plus 5. Please get it in your mind. The differentiation of 5 like thing 0 because 5 is just constant. Okay. The fifth one, y equals 3 over 2x squared minus 5 over x squared plus 2 over third root of x plus 2x plus 5. Okay, do those things. Mahali, especially if you have any problem in these things, don't hesitate and ask me. Okay. Do you know we should differentiate trigonometric functions also. We should differentiate trigonometric functions also. So before that, I should teach Mahal to trigonometry. And I think it is better for Sophia and Sunil also. Join the trigonometric session for Mahal. I think you also can remind the trigonometric theories. In future, there are there are we should differentiate trigonometric functions. So for that, we want the trigonometric theories better. Okay. Okay. Do these things. Okay. I asked him. Okay. Sunil, what's the number of the problem that now you write? What's the number of the problem? What's the number of the 1, 2, or 3? What's the number of the problem that you are going to? Sunil? Sunil is not speaking. Sophie, what's the question number that you are going on? 3, 2. Maheni, what about you, Maheni? 2. Okay, okay. Now, what is the? I can erase now. Okay, what's the question number? Okay, what's the question number? Oh, 180. What's the question number that you're looking? Maybe was the question number? Any problem or something? I stuck in any place? Hello. Yeah, no, yes. Okay. Okay, it's no problem. Hmm. Uh, it is possible. It's okay. Please wait. Okay, just wait. At what time? At what time? Oh, yeah, okay, okay, okay. Recording also okay. I can give you recording. It is okay. Yeah, sure. Practice questions again. Okay, okay, okay. Thank you, man. Okay, I will give you recording at what time. Uh, you need to leave. It's just now. Oh, it's the time. Sunil. Hmm. Sunil. Sunil නම් හැමදාම ප්‍රශ්න දිනනවා නේද? Maheli, because our Sunil, because we finished class in like nearly 10:15 or 10:30. Okay, you small, small time.
සර් ටිග්නොමෙට්‍රි ටික දැම්මේ නැහැ නේ වෙබ්සයිට් එකට.
10:30 rumah main, 10:30 Sunil, 10:30, 10:15 lagi ano?
සර් ටිග්නොමෙට්‍රි ටික දැම්මේ නැහැ නේ වෙබ්සයිට් එකට දාන්න.
Yeah, you Sunil. I think it's very important. No, not here, not here. Maheli, at what time do you want to leave? Just now or after some? Yes.
තාම කියේ නැද්ද සර්?
What the?
තාම කියේ නැද්ද?
Dia tu block tell me. What?
ඇහෙන්නේ නැද්ද කියලා අහන්න සර්.
I know. Like, okay, okay. This is okay because we have some headache. It's also better rest you. Okay, get some rest. It's no issue. And I will give you the recording. No issue in it. But watch it down. Our the recording. Okay. Welcome. And can you watch the whole recording? The remaining part of the recording tomorrow. Is it okay? Tomorrow, I am asking for my okay. Watch it tomorrow, okay? The recording. I will give you. Okay. Sure. Okay. Okay. No issue. Okay then. Okay. Uh, Ganga, I will give you the recording. And I monitor. Please watch it, okay? Please watch it quickly, yeah? And cover it quickly. Okay, then. Goodbye, my get some rest. And I wish you speak recovery, okay? So wait, what's the question number? All finished? Fifth one. Sunil, ඔක්කොම කරාද? මම මේක මකන්න. ඒකයි එහෙනම්.
හතර වෙනවන් කරන්න පුළුවන් හතර පොඩ්ඩක් අමාරුයි.
හතරනේ. මේක අපි ආන්සර්ස් ටික දෙන්නත් එපා ඔයාලට නේද? ඉස්සෙල්ලා ආන්සර්ස් ටික චෙක් කරගන්න බෑ. ෆස්ට් one.
සර් මේවා ඔක්කොම ටික වෙබ්සයිට් එකට දානවා නේද?
මොකද්ද?
මේ ඔක්කොම අර ටිග්නොමෙට්‍රි ඔක්කොමයි ටික වෙබ්සයිට් එකට දානවා නේද?
මොනවා මේ රෙකෝඩින්ග්ස්ද
ඔව්
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 රෙකෝඩින්ග්ස් ඔයාලා රෙකෝඩින්ග්ස් වල කියනවා සුනේ
මට ටික් ටික තිබ්බනම් ඇතිද ඊට
ටික
පස්සේ
කොහොමද ආයෙ කරනවා ටික ටික ආයෙ කරනවා මේ රෙකෝඩින්ග්ස් වල දෙන්නම ඕන ටික කොහොමද මුලින් කරන්න යනවා ළමයා මේ આવුත් මේ ළමයා අර මේ සික්ස් එකකට දෙන්න බාක ළමයා මේ කොහොමද කතා කරන්නේ ඉඳා මේ එදා මොකද පේමන්ට් එක කරන්න ලෑස්ති වෙලා ඊට පස්සේ මගේ ක්ලාස් එකට ඇවිල්ලා ඉන්නේ කියලා. එතකොට දැන් ඒ ළමයා මේ සෙපරේට් ක්ලාස් එකක් වගේ ඉල්ලුවා මේ ට්‍රිග්නොමෙට්‍රි කරන්න කියලා. එතකොට රෙකෝඩින්ග්ස් නැතුව ට්‍රිග්නොමෙට්‍රි කරන්න නේද? එතකොට මේ ඒකට සෙට් ඒකට සෙට් කරලා තිබුණා රෙකෝඩින්ග්ස් දෙන්න ඊට වඩා අර ෂේප් මේ ට්‍රිග්නොමෙට්‍රි සෙට් එක ගොඩ දාමු. එතකොට මුලින් නම් මේ ඒක බය වෙන්න එපා. May final answers to so we you will guess the final answers, no? The answer for one is these are answers, 15x squared. The answer for two 9 over 4 root x 9 over root x. These are answers, Then the answer for 3 15x to the power 4 minus 7 4 3x squared minus 3 over 2 root x plus 1 over x squared. 5 3x plus 10 over x cubed plus 2 over 3 dot 1 over x to the power 2 over 3 plus 2. These are the answers. And Sunil, do you have any you have some problems in 4 questions, no? 2 and 3 okay, Sunil? Is it okay? 2 and 3? Sunil, quick response.
yes sir
2 and 3 okay? It's okay, 2 and 3. Okay, you have problems in 4, no?
yes
Yeah, right. 5 equals x cube minus 3 root x minus 1 over x plus 5. Then dy over dx equals c. So wait, is it okay all answers? So wait, any error things or anything, any issue in your answers? 3x squared minus in here 3 half Sunil. මෙතනදී case එක කෙලවුනේ. මෙතනද? මෙතන සිද්ධිය වෙනවනේ. මේ මම එකපාර ගත්ත එක තේරුණාද?
අර රූට් එක half වෙනව නේද
අන්න හරි root එක half වෙනවා. ඕකේ හොඳම දේ තමයි Sunil. 70ක ඔය maths හදනකොට always keep the rough paper with you. Always keep the rough paper with you. Okay? Then you can write these things on root x to the power half. Then you can just get these things half x half minus 1. I told you earlier half minus 1. You should get directly these things. That's the thing. Then you can just substitute. So these are not papers. So first 4 correct, but fifth only one. Okay, just wait. First 4 correct. For fifth one, only I didn't get 2 over 3. Others all I got only 2 over 3. Didn't. Okay. Please wait, sir. Please wait. So then, now this also meaning rough papers. 1 over x means x minus 1. And get this minus 1 in front and x minus 1 minus 1. So minus x minus 2. Therefore, please be careful. This minus is here. And for this 1 over x, we put in minus x to the power minus 2. And the differentiation of constant is 0. Sunil, is it okay? Okay, 3x squared minus Sunil, is it okay to write this as this? Write this as this? Is it okay?
आपका उसका
Two x to the power minus half means root x. Now this becomes positive and x to the power minus 2. And you can write this as 1 over x squared. So the answer is okay. Sunil, okay, Sunil, okay.
Okay,
I think Sunil is better. You put some text, you drop some messages. I think it's this, but I can't really hear you. I think that's raining or something, no? It's raining. I want to know for Sunil, this fourth question is okay now. That's the thing. I need to know that. Sunil. Ah, okay. Now the topic is problem. Sunil, keep reminder, keep a cut or rough paper with you when doing these things. And after these things, I will put some summary about these differentiations and about Sophie. Your question is okay. Your question is this, no? Okay, right. The fifth question. The fifth question is y equals 3 over 2 x squared minus 5 over x squared plus 2 over definitely we need a rough paper to solve this. 2x plus 5. The rough paper is my rough paper is this part. Okay. dy over dx. 3 over 2. 2 x minus 5. In my rough paper, I put x to the power 2 as x to the power minus 2. If that no, 1 over x to the power 2 means this x to the power minus 2. Then getting minus 2. Minus 2. Please see how I put in these things up. Please see how I handle the numbers. Minus 2, x to the power minus 3. The bracket usage plus 2 into this 1 over this. This means this. This means this. Very easy. Huh? The differentiation is minus 1 over 3, minus 1 over 3, minus 1. In separate place. Get this minus 1 over 3, minus 1. Common denominator. Minus 1, minus 3. It is minus 4 over 3. Minus 1 over 3, x minus 4 over 3. From here, minus 1 over 3, x minus 4 over 3. This. Now this 2x is 2, no? 2. 2x, differentiation of 2x is 2. Huh? It's because how is 7? 2 into 1 minus 1, so 2. This is 0. Now Sophie, 2 and 2 will cancel out. Then 3x is also okay. 3x. Minus 5 into minus 2 plus 10 over x cube. And this is minus. Okay, this way. 2 or 3 is okay. Then why is it class is positive? No? This way. Yeah, it's a my mistake, Sophie. I think if it is the question, it's a problem. No, you are no error. You are no wrong because it's my mistake by me by writing answers. Then not happen. Then no, so this is just minus 2 plus minus 2 over 3. And here, yeah, it's 4 over 3, no? It's not 2 over 3. Why is that? It's not so. It is in answer. The problem in answer, so we don't get that. The answer is wrong. This is the answer. I think so. You get this. This is the answer. Now, okay, so I think your answer is correct, I think. The wrong, yeah. Sunil, what up there? Fifth question. Sunil, Sunil, okay, okay then. Nanda, Sunil, but yeah, don't like not yan that, doing correct one. Oh, Sunil, then it does not pay. There are instructions also. Okay, we should do in July, in June, I think in June, 2 classes. There are 2 more classes to do in June month of June. Okay. Okay. Write down new topic. Write down new topic. Summary. Summary of summary of differentiation. Summary of differentiation. So when writing Q to Q in big. Yeah. Okay. 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 Sure. Thank you for the idea. Yes. Don't. I didn't read your message completely. When writing, you go separate because it's not clear enough. Oh, yeah. I can understand. Yeah, you're right. Okay. Summary of differentiation. We say they are coefficients. Okay. We say they are coefficients. The equations that we get. The first thing is this. The things that you should keep in your mind. That is key. Tell me, if y equals x, what's the differentiation? Dy over dx. These things you should get directly without any simplification. So what's the answer? Y equals x. If y equals x, what is dy by dx? 1. This is a one thing. It's a very easy, simple thing that you should keep in your mind. Second one. Second one also very simple. The k is a constant. Then what is the value of dy over dx? What's the value of dy over dx? 0. Very good. Sunil उत्तर देना है. Sunil meeting के अंदर. No. उनको उत्तर देना है. Sophie, can you tell me the differentiation of this derivative? You should keep it in your mind. The differentiation of no, differentiation of this also you should keep in your mind. You should write it directly in our simplifications, in our complex simplifications. You should write this also directly. Can you write it? Can you remember it? What should be the answer? Please keep it in your mind. Don't worry. Don't think about. Oh, very good. Yeah, that's the pattern. Anything in square root, keep in this denominator. Anything. If there is a flower, see, if there is a flower in square root, then what's the dy by oh, see, dy by d flower. That's the interesting part. The dy by d flower is 1 over 2 root flower. Okay. Yeah. Interesting, no? Very interesting. Yeah. That's the theory. Now, that's fourth conclusion. That is y equals 1 over x. Then what is dy by dx? Okay, now this fourth line is right. Dy by dx is minus 1 over x squared. That's why for that also we can that sum get that if this y is 1 flower, then dy over d flower, not x. Now minus 1 over the square of flower. Yeah, these are the main four pillars. The main four pillars that you should keep with your in your mind when we simplifying very complex differential problems. Okay, then these are the four pillars. Then after this, uh, there's a chain rule theory and trigonometric differentiations also. Okay, please write it. Sunil, quickly write it up. Sophie, quickly write it. Sunil, I'm not worried. බලන්නකො Sunil ඉන්න පුළුවන් උඩරම ටයිම් එකක් ඉඳලා අපි යන්නේ. ඕකේ ස්නැප් මම තුනෙන් මේ හැමදාම මේ ඔය වැඩේ යනවද? ඒ කියන්නේ හැමදාම යන්න වෙනවද මේ ටයිම් එකට? දැන් මේ යන්න ඕනේ මේ පිළිවෙල වලින් පස්සේ අපිට කරන්න වෙනවා 11 විතර නෑ 12 විතර වෙනවා කරන්න වෙනවා. අදට අවුලක් නෑ. වෙනදට පොලිස් වල තියෙන 11. දැන් ඔය පොලිස් එකේ හැමදාම බදාගෙන තියෙන ඕක පොඩ්ඩක් ඒ සරට කියන්නකෝ. මේ ඒක පොඩ්ඩක් වෙනස් කරගන්න පුළුවන් කියලා අහනවා. ෆිසික්ස් එකක්ද? ඒ කෙමිස්ට්‍රි. ඒක වෙනස් කරගන්න බැරි ඔයාලට. පොඩ්ඩක් වෙන දවසට. නැත්නම් අලුතෙන් ටයිම් එක හරි රෑ 1ට විතර දාන්න ලොකු ඉස්සෙ. හෝල් ක්ලාස්. හෝල් ක්ලාස් හරි. මම කියන්නේ සර් මේ කාටද සර් ඉන්න කාටද ටැග් කරන්න. අනේ පොඩ්ඩක් බලන්න බැරි දැන් යන්න ඕනේ. ඒකනේ. අනේ පොඩ්ඩක් බලන්න. God bless you. Thank you. Hari. Good night. Okay. So wait. So if these things okay. So wait. Okay. These things. Okay. Sorry. Okay. Okay. I will put the homework. Homework questions into the group and the next theory is chain two. You have to okay. Next theory is chain two. Okay, I should redo that next thing. In end of the July, we can extend our classes. We can extend 2 classes per week. Then chain rule. I will put the homework problems into group. Okay, I will put the homework problems into group. Then okay, okay, Sophia. I think we know any questions for you. You perform just do it. The differentiation also not long, no? Not long. We can finish differentiation. Not going on 1 month, 2 months, or no, 2 months. I think maximally will take only 1 month to cover the differentiation. Maximum, yeah, with do it questions. So no worries. After that, we can start. Okay. After that, we can start integration. But before that, we should cover trigonometry also. I think it is better for you also. Okay. Trigonometry. Those are things. Okay. Then. Good night and do your hard work. Exam after doing yours. It's okay. I'm very sorry. I'm forgetting to find the about the exams. I think so. Yeah, after A level, I think we can't apply GID exam. It should be applied in the during in the A levels time. Do you apply A levels in private or from a school? How you apply A level in private or in from a school? That's the question, no? So, okay, so give me 1 day, give me 1 day, give me 1 day, I will definitely find, help you with the things. And do some help, do me help. The help is reminding. If I mean, very busy schedule, okay? I mean, very busy schedule. So, proper message. So, did you find that? Did you find that? Again and again, it's no issues, but remind me, then I can find that. Okay. Okay then. Nice, okay. If you have any doubt or thing, even you can ask in this time also. Otherwise, we can end the session for today. Okay, welcome. Good night, Steve. Goodbye. Okay.